Hey there, welcome back to 8.8, and what we are talking about is average rate of change using exponential models. So you guys have talked about average rate of change before. You should be very, very familiar that average rate of change is rise over run, and that essentially is delta y over delta x. Well, we're working with exponential functions, so instead of delta y's, we'll have function values, right? F of 1, f of 2, f of 3, so on and so forth, right? So we end up getting this equation for average rate of change. It's the change in your f of x values over the change in your x values, right? Or f of x2 minus f of x1 over x2 minus x1. And I tell my kids, remember it maybe too also as this, right? This is delta y over delta x. It's just the difference in your y values divided by the difference in your x values. Plain and simple. Okay. All right, so let's go ahead and look at a first example here in context, and it says a chemist studying the effect of a new insecticide has determined the mathematical model for an insect population treated by a chemical as P of D equals 216.8 times 1.8 to the power of negative 2.56 D, where D is the days since the application. So here's our function. D is the days since the application of the product, and P is in thousands. What is the average rate? So here is the question. What is the average rate at which the insect population is changing per day? From 1 to 4 days after application, round to 3 decimal places. Okay. So they want to know what's average rate of change. Well, average rate of change, I need 2 points. Now, they do give us an interval. Again, here is our interval from 1 to 4. So there's your x1, x2. But more importantly, I don't have any y values. I don't have any outputs. I don't know what is the insect population on day 1 after the application of the chemical, and then 4 days after the application. So what we have to do is we have to go ahead and calculate what is P of 1. So we'll take our formula or our function, and we'll go ahead and evaluate it. Okay, so let me cruise on over to the calculator. Okay, and here is our function evaluated, and we get 48.1462. Now, it's important to note that, again, the insects here, right, that this is in thousands. So I really want to take this value and I want to multiply by 1,000. So I get 48,146.2. Now, I have a problem here. They want us to round to 3 decimals or more. So I want to go into my settings. If you're using a TI-30, it shouldn't be an issue, but I just want to make sure that I can see as many decimal places as possible here. So I'm going to go back, re-enter this. Here we go. And we get 48,146.161. So this times 1,000 is equal to 48,146, I believe. Yeah. 0.161. Okay, so that's after 1 day. Now I want after 4 days. What's the population after 4 days? So we're going to go ahead and do the same thing, but evaluate at 4. Okay, 0.8 times 1.8 to the power of negative 2.56 times 4 times 1,000. Okay, and if you evaluate this, you should get 0.527, but again, we need to go ahead and calculate, what is this times 1,000. So I'm going to go ahead and take this value and multiply by 1,000. And we get 527.313. So 527.313. Okay. All right, so I have my two output values. Now what I need to go ahead and do is I need to go ahead and calculate the average rate of change. All right, so average rate of change is going to be delta P of D over delta D, okay? The change in the population, right? So P of 4 minus P of 1 over the change in the days. 4 minus, whoa, not 3. I was jumping to the answer. 4 minus 1. Okay, so we'll plug in these values. So 527.313 minus 48,146.161 over 3. Okay, and we get approximately negative 15,872.949. Okay, so that is our average rate of change, okay? This is a context problem, so we need to go ahead and answer in context. So we can say from 1 to 4 days after application, the insect population is decreasing at an average rate of 15,872 and 0.949 insects per day. All right, and this is approximate, so I want to use the word about is decreasing at an average rate of about. Okay, roughly. All right. Okay, so there is the example. I'm going to go ahead. I'm going to show you another example practice problem, and you'll notice that this one doesn't give you a function. It gives you a graph, which I kind of think are easier, but please pause the video. I want you to try this. Please calculate the average rate of change here. All right, hopefully you have paused the video and tried this. I want you to note that the average rate of change is found by estimating the values here. So in 2001, that's 6 years after 1995, and then in 2013, that's 18 years after. So you'll get those 2 points, and there's how you find your values, okay? Also note that to the axis, it tells you that this is in hundreds of dollars, so you have to multiply by 100, okay? Watch for those. All right, here is the second practice problem. Please pause the video and try this example. And then again, too, I'll give you a hint. Okay, so here you go. Pause the video. And here is the solution. All right, so that is it. That is average rate of change in context with exponential models. Catch you next time. Peace out.